one-way analysis of variance, okay? So the one-way analysis of variance, it is a statistical test, an inferential statistics that is used also to compare. It is actually an extension of t-test, only that the t-test is used to compare two group means. Okay, you're comparing two groups, the mean scores of two groups. However, in one-way analysis of variance, you are in a situation wherein you have three or more groups. And you want to compare them. And you want to test whether there is a significant difference among these three groups. So you will be using one-way analysis of variance. And one way of analysis of variance is used if you have one independent variable and that independent variable has three or more conditions. That is why it is called one-way analysis of variance. However, there are certain situations that involves two independent variables. And that two independent variables have two or more conditions. So in that condition, you will be using two-way analysis of variance. So when do we use one-way ANOVA? It is used to determine whether there are any statistically significant differences between the means of three or more independent or unrelated groups. It compares the means between the in and determines whether any of those means are statistically significantly different from each other. So specifically, it tests the null hypothesis. Yes, the means of 1 is equal to the means of 2 is equal to the means of 3 until up to how many groups you have. So this is now the mathematical equation of your null hypothesis. Your alternative hypothesis, however, says that there is at least two group means that are statistically significantly different from each other. So unlike t-test, wherein there are one-tailed and two-tailed hypotheses, in analysis of variance, there is only a non-directional or two-tailed hypothesis. So it's just, is there a significant difference or no significant difference? So in analysis of variance, it is an omnibus test, meaning to say it just wants to know if there is significant difference across all groups, not necessarily determining whether the difference is higher or lower. For example, in this particular study, where the problem is, does different pacing strategy affect time to finish a marathon? What do you think is the independent variable in this study? Yeah, the independent variable is the pacing strategy, and the dependent variable is time to finish a marathon. Okay, so suppose you are a trainer, a coach. Okay, suppose you are a coach and you want to know what pacing strategy would be more effective. So you try to randomly divide your athletes into three groups. Excuse me. You try to divide your athletes into three groups. One group would be assigned to a pace where they would start slow, then increase in speed. Then the other group would start fast, then slow down at the later part. And then the other group would run at steady pace. Then after that, you get all their time and try to compute, get the descriptive statistics. Now, then you will now run an analysis of variance of their scores to see if there is significant difference. Now, before you run an analysis of variance, a one-way ANOVA, there are assumptions that you have to meet. The first one is the dependent variable is normally distributed in each group. All the scores in the time to finish, the dependent variable scores of your three groups should be normally distributed. Then that should be determined by your real stat. If you compute for descriptive statistics, your Shapiro-Wilks, your D'Agostino-Pearson, so that the skewness and the kurtosis, so you will be able to determine whether the scores are normally distributed. Then there is an assumption of homogeneity of variances, meaning to say that the variances of your groups should be homogeneous. It should not be significantly different. So you can determine this by using Leven's test, the Leven's test. So this is in the real stat also. You can determine this. Now, the third assumption is independence of observation. This means to say that each participant in your study should be serving only one condition of your independent variable. So if I am an athlete, I serve in the steady pace condition, I should only be serving there in the steady pace condition. I should not be serving in the other two conditions. Then the dependent variable should be continuous, meaning to say the dependent variable should be measured in the IR scale. So for example, time in seconds. So that should be in time measured in seconds is a dependent variable that is measured in a continuous scale. That should be ratio scale. Now, what if I don't meet these assumptions? The one-way ANOVA is considered a robust test against the normality assumption. So it is very healthy. Kumbaga sa ano, it can endure some violations of normality. However, if you have a small group size, meaning to say your sample size for each group is below 20, it may suffer from the profound effect of platycortosis. So if in this case if that happens, you may use Kruskal-Wallis H test, which is available in RealStat, or you may transform your data, transform it into z-scores, and then you proceed with one-way ANOVA. But still, it's still best to use the raw score data, the original raw score, than the transformed data. And when homogeneity of variance is violated, which is an assumption for one-way ANOVA, if this homogeneity of variance is violated, one solution would be to run a Wilks test. And a lack of independence of cases, ito yung isang assumption that observations should be independent. A lack of independence of cases has been stated as the most serious assumption to fail. Kasi sa nasa researcher na, it's not on the scores, on the data itself, but on the researcher. The researcher should have initially made sure that the observations were independent. Now, after conducting the one-way analysis of variance, we also conduct post-hoc tests. These are a posteriori tests, after the fact tests. You do this after conducting the analysis of variance, particularly if you have found out that there is a significant difference among the groups that you have tested. One Way Anova is an omnibus test. It only detects whether there is a significant difference across all groups. However, it does not specifically tells you which group have had the significant difference. Okay, you would be making pairwise combinations of all groups. For example, if you have three groups, then if you pair up all the three groups, you will come up with three pairs. Kunwari, group 1 will be paired with group 2, and group 1 will be paired with group 3, and group 3 will be paired with group 2. So there will be three possible pairwise combinations. And post-hoc test will tell you which among these possible pairwise combinations did the statistical difference lie. Okay? Kasi it is possible that in two pairwise combinations, there are no statistical differences, but in only one pairwise combination, there the significant difference lie. So that would be a point for analysis. Then aside from post-hoc test, we also compute for effect size, which is also available in RealStat. The effect size, it is what we call the practical significance, because we are not only contented with knowing whether the difference is statistically significant, but we also want to, how much is the difference? How big is the difference between these two that are being compared? So hence, we want to know the effect size because this is the one that has a practical significance. Kasi maybe there may be a difference, but the difference is only small. And you cannot detect that by doing only an F-test or analysis of variance. You have to proceed with computing for effect size. So your RealStat will spew that data out, the effect size. Now, there are three kinds of effect sizes that the RealStat will tell you. We have here the eta squared, the RMSSE, the root mean square of standardized effect, and the omega squared. The eta squared, this is also like the R2 or the R squared, the coefficient of determination. And this is an estimate of the sample. Okay, yung sample mo, the actual data that you are gathering. Then the omega squared, however, it is an estimate of the population. Well, we will understand this more when we do an actual testing. Okay, so we have an exercise here. Okay, we have here a teacher, kunwari kayo. You are a teacher, and you want to know, would there be a difference in learning performance among your students who would be subjected to three different teaching methods? One teaching method would be lecture condition. Then the other group would be lecture with reading condition. And then the other group would be film. Your teaching method would be using a film plus reading condition. So, then you obtain their scores on a test. You tested their learning performance by giving them a test. And you got their scores. So the first thing that you do is you state the problem. So here is the problem. Is there a significant difference in learning performance among the three classes that use different types of teaching methods? So your null hypothesis would state there is no significant difference in learning performance among the three classes. And your alternative hypothesis would say there is a significant difference in learning performance among the three classes. You set your alpha at 0.05. And your decision rule would be If p-value is equal to or less than 0.05, then we reject the HO and accept the HA. Okay, so unang muna is testing for assumption. Normality of distribution. Before we proceed with the one-way analysis of variance, we have to test for normality of distribution. So how do you do this? Ito kasi nagawa ko na ito kaninang umaga. So I'll just show you how to do this. Well, Control M, you have done this before. We did this, descriptives. Control M. Then we have descriptive statistics. We click OK. And we put the input range. You just highlight all three columns. So we have here. There. And then I uncheck this box plot with outliers. And we choose an output range here. And we click OK. So ito na siya. Ito yung lumabas. And we will look at here, the Shapiro-Wilk says that in all these three conditions, the lecture condition, the lecture plus reading, the film plus reading, they are all normal. Normal, Shapiro-Wilk says, yes, yes, yes. The Agostino-Pearson also says that all three groups are normal. And if we will look at the kurtosis and skewness of all three groups, you will see here that they are almost, they are all near to 0. So the data are good. All of our groups follow a normal distribution. Next, so normality of distribution is okay. So this is met. Next, homogeneity of variance. You can do this by doing already the analysis of variance. So again, Control M, press Control M together. Click ANOVA, then click one factor ANOVA, and you just input the range. Again, we go back here, input the range of our data. Okay, so yan, nakapasok na. The range of our data is already filled in. And we have the input format, Excel format. Then we check ANOVA here for the omnibus test option, meaning to say, for testing of significant difference across all three groups, we check ANOVA. And if we want to know if there is homogeneity of variance among all three groups, we check Leven's test. Yan. Now, in case you think that the homogeneity of variance is violated, you may check Wilks because it will spew out also the computation of Wilks. Now, for the follow-up option, this is now the post-hoc analysis. For you to know which pairwise combinations lie the significant difference is, then you check 2K HSD. The 2K HSD is used if you have group sample sizes that are equal. So para-pareho ng size ng sample. Or like this one, they are all 9 students per group condition. The Bonferroni, you click Bonferroni for alpha correction, because as you increase the number of groupings in your analysis of variance, you also increase your alpha, your type 1 error. in order for you to decrease that alpha error, para nasakto lang siya, it will remain at 0.05 alpha, we do some correction. So we check Bonferroni. And then we input our output range and click OK. Hindi ko na siya gawin. Andito na, lumabas na siya. Una, nilabas niya. Nasaan na yun? Ito. Nilabas niya. Kasama na rin ang Levens test. The Levens test says that the p-value for the variances of all the means of these three groups, it's 0.99. So in the Levens test, it's also hypothesis testing. The null hypothesis is set as there is no significant difference in the variances of the group, meaning to say homogeneous. And since the p-value of our Levens test is 0.99, it is higher than the alpha 0.05. So therefore, this null hypothesis of no significant difference is accepted. So we accept. So we now assume that the variances of all three are the same. So we can proceed. This assumption of homogeneity of variance is not violated. We can proceed with the F-test or the analysis of variance. And this independence of observation, it is okay. Dependent variable is continuous. It's okay. Approve lahat. All of the assumptions for performing one-way analysis of variance were met, so we proceeded. Okay, so this is the other data that is being spewed out by RealStat. You will see the descriptive statistics is given by RealStat. So there are 9. The count here is 9 for each group. 9 in all groupings. Then the sum of their scores are here. And then the mean score are here. And then the variance is given here. Wala yung SD. It's the variance. However, it's easy to get the SD. You just get the square root of the variance, then you have the SD, just like this. Ito, this is the SD. I manually computed for this. The SD for the condition 2 is 5.33. I got this by this formula, square root of SLG68. This is now the main ANOVA table, analysis of variance table. The analysis of variance table would tell you the variation, because again, the analysis of variance, it partitions, okay, the variation between groups, okay, the variation that is due to differences across all groupings. And then also the variation of scores within each group. Kunwari, I am an athlete, I belong to the steady pace condition. My score will differ from all the scores across all groups, across all three conditions. And it will also differ, my score will also differ across all the scores within my own group. So that is within group variation. Now, if you want to prove our thesis that there is significant difference between all these running conditions or learning conditions, we want that this between groups would be higher than the within group variation. Okay, so SS, sum of squares, means SS means sum of squares. So we have the sum of squares for between groups variation is 408. And the sum of squares for within groups is 671. Now, this is the degree of freedom. This is the degree of freedom for between groups. So that would be 2. And the degree of freedom for within groups, that is 24. So if you divide the sum of squares by the degree of freedom, so 408.07 divided by 2, you will get this mean square. MS means mean square. Then you will get 204.037. Now, if you divide 671.77 by 24, then you get this 27.99. The same thing also for the total groups. Okay, 1079 over 26, then you get 41.53. Now, this is now the F value or the F ratio. The ratio between the between groups and the within groups variation. So how did we get this? You just divide 204.03 by 27.90, and then you have this value of 7.28. Now, what is the corresponding p-value of this F value? Its p-value is 0.003. Again, our decision rule is to reject our null hypothesis is that if p-value is equal to or less than 0.05, then we reject the null hypothesis. What is our null hypothesis? That there is no significant difference in learning performance among the 3 classes. So, kita natin, so we see here that our p-value is less than 0.05. The p-value, the actual p-value is 0.00, which is less than the alpha level of 0.05. So therefore, we reject the HO. We reject the HO and accept the HA. Okay? Now, post-hoc analysis. Since overall, okay, across all groupings, there is significant difference. And since we have checked the 2-key HSD, 2-key will now spew out these tables here. The critical value for 2-key is 3.53. Now, 2-key now tried to compare, made a pairwise combination of all 3 groups. So the formula for us to determine how many pairwise combinations should we have if, okay, what is the formula? The formula is here. K multiplied by K minus 1 over 2. So if you have 3 groups, so that would be 3 times 2. Kasi K minus 1 is 2. So 3 times 2, that would be 6 divided by 2. Then you have 3. K is the number of groups. Now, if you have 4, then you will have 6 possible pairwise combinations. Now, this is now the Q, the value, the critical value, to which our actual value, our Q stat will be compared to. Our Q stat should be higher than this critical value, or we can simply look at the p-value here for us to see which pairwise combination is statistically significantly different. So if you will look at here, the lecture condition against lecture plus reading condition, it is not significantly different because the p-value is 0.07. The Q-stat, it is 3.27, lower than 3.53. And then the p-value is higher than the alpha level of 0.05. So it is not significant. This pairwise combination is not significant. Now, condition 1 against condition 3, that is film plus reading condition, the p-value is 0.32. Still, this pairwise combination is not significant. Look at the Q-stat, it is 2.07 against 3.53. So, mas mababa siya kaysa dito sa critical value. And then the p-value is mas mataas, is higher than 0.05. So, it is not significant. So, let's put here not significant. Then, the third pairwise combination, that would be between lecture plus reading condition and then the film plus reading condition. It is significant. It has a p-value of 0.0025 and its Q-stat is 5.35, which is higher than 3.53. Hence, it is significant. So, among the three conditions teaching method, the significant difference really lie only between lecture plus reading condition and film plus reading condition. So, yan na po siya. So that is post-hoc analysis using Tukey HSD Kramer. You use this if you have equal sample sizes that are equal. So pare-pareho yung sample sizes ng mga natin, groups. So we use Tukey HSD. Now for the effect size. The effect size again will tell you how big is the difference. There are three effect sizes that is given to us by real stat. The eta squared, it is equivalent to coefficient of determination. So we have here a value of 0.37. Actually, it's 0.38. So the eta squared, so this is, ito yung symbol na eta. Yan, eta squared. The eta squared, the eta squared is equal to 38, actually 37%. This would read as 38% of the variance in learning performance can be attributed to the teaching method used. And this is an estimate of the sample. Then the omega squared is the same as the eta squared, only that this omega squared is an estimate of the population, not of the sample. Now for the omega squared, it is 0.31, or actually this is already 0.32. So for us to know whether it's small, medium, or large, we just look at this values here. If the omega squared is 0.01, that would be small. Now if it is 0.06 to 0.13, that would be medium, and 0.14 and above would be large. So we have here an omega squared of 0.31 or 32, that would be a large effect size. We also have another form of effect size here. This is already around 0.90. Okay, so we have here that is very large according to this scale for interpretation. Now you just choose which among the eta squared, RMSSE, or omega squared would you use for your reporting. Now, so this is now for reporting of your result. The first statement would be, you would have to state the objective of your study. So you would see here that a between subject design was performed. This is now a name, a generic name for a research design between subject design, meaning to say the three groups, this is not a repeated measure design. This is not a within subject design, meaning to say each participant in the experiment or in the study served only one condition of the groupings that you made. So a between subject design was performed to what? To test the difference in learning performance using different teaching methods. So this statement here is the objective. Now what's the result? Result shows that there was a significant difference in learning performance. So nandito na yung conclusion. That there was a significant difference in learning performance among classes using different teaching methods. Okay, the F, this is the F. The F tells us what statistical test was performed with the degree of freedom of 2 on 24. So this is the degree of freedom for between groups and 24 is the degree of freedom for within groups. Kaya makita ninyo. Ayan siya. Has a corresponding p-value of 0.003. So the class using lecture with reading condition had the highest learning performance with a mean. So these are now the descriptives. Mean of 91 and SD of 5.34. The group with the lowest mean learning performance was the group with film and reading condition. Ayan, with a mean of 81.56, standard deviation of 5.31. Post-Hoc analysis using 2 key HSD reveals that significant difference lies between the film with reading condition and the lecture with reading condition. The probability is 0.002. Further, this study shows that 37% of the variance in learning performance can be attributed to teaching method used. So, this is now the effect size. You only perform the effect size, report the effect size if the F is significant, if the analysis of variance is significant. Otherwise, you don't need to report the effect size kung hindi naman significant initially. So that's it. That is your one-way analysis of variance. So you have learned today. Okay, how do we know pala how many samples? By using the G power, if you plan to use a one-way analysis of variance, you use the G power. So we have the F test. This should be a priori. Before you conduct the study, you should determine already how many samples do you need. So F test, one-way analysis of variance is under the family or test family of F test. Then click down here and use ANOVA. ANOVA Omnibus one-way. You don't use the ANCOVA, the ANOVA. And then a priori. Let's say you want to determine the number of samples with an effect size, medium effect size. So, dito siya. Kita nyo, lalabas yan. Small effect size would be 0.10. Medium effect size would be 0.25. And a large effect size would be 0.40. And you set your alpha level at 0.05. And say, for example, you set your power at 0.80 because that is the standard, and your groups would be 3. You have 3 groups, kunwari. So you calculate. So overall, you would need 159 respondents. And if you divide that by 3, you would need at least 53 respondents per group. So that is your G power, determining your number of samples using G power for a one-way analysis of variance. Okay, so this afternoon you have learned about one-way analysis of variance, how to perform one-way analysis of variance using real stat, interpreting the results, computing for the effect size and the post-hoc analysis, and computing for the target number of samples using G power. Okay? That's it.